Hello class, so we're going to start off with question 340. This is a voltage question. So most scenarios in the real world that can be modeled using a sine or cosine curve have something that reaches a minimum and then reaches a maximum and just kind of repeats that process, which is why it would be modeled with a periodic function. So in the case of voltage running through an electrical socket, the voltage would probably hit a minimum to keep up something working, up to a maximum value without shorting out, and just repeat that. So that's kind of what's happening here. Let's read this question more carefully. It says, the voltage used by most households can be modeled by a sine function. The maximum voltage is 120 volts, and there are 60 cycles every second. Which equation best represents the value of the voltage as it flows through the electric wires, where T is time in seconds? All right, so that's our question. Looking at all the answers, we know that the amplitude has to be 120, just because those are the only possible outcomes we have here. So just based on that, we can sketch a graph. Most of these questions can be answered by sketching a graph. So 120 is going to be the maximum voltage, and negative 120 is going to be the minimum voltage. Our next axis is our t-axis, or time. This is a sine curve, so it's going to start by going up from the midline, not from the top. That would be a cosine curve. So we're going to approach the top, then we're going to go back to the midline, then to the minimum, and then back to the midline. So our graph's going to look something like this. But this does this 60 times in 1 second. So that means this first curve, which is the period of this graph, so this is one period, is only 1/60th of a second. So the period is 1/60th. Okay? Now the frequency is how many of these fit into 360 degrees. Now this is one of those problems where our answer should have a pi in it, because that's usually what happens when the curve doesn't end on a multiple of pi. So we can probably eliminate these two at this point in time. So we need to find the correct frequency. So in order to find the frequency, we need to know the period. Now the period, again, is only 1/60th of a second, not 60 seconds, not 1 second. So let's use the formula here. So there are two formulas we know. That is, the period is equal to 2 pi divided by the frequency, which is b, and the frequency is equal to 2 pi divided by the period. So either of these formulas would be usable based on what we need. Now in this case, we're going to need our frequency. So the period, as we saw, was equal to 1/60th. So we're just going to plug that in for our p-value and then solve. So the frequency is going to be equal to 2 pi divided by 1/60th. So I'm going to turn the numerator into a fraction so we can use keep, change, flip. So that means that the frequency will be equal to 2 pi over 1, and we're dividing, so we're going to change division to multiplication, and we're going to find the reciprocal of the fraction. So that's 60 over 1. So our frequency will be equal to 120 pi. So that means if you multiply 120 by 3-ish, that's about 360 of them in 360 degrees. So, or 360. So our answer is choice 4.